In this question, you have a rectangle is inscribed in a circle of fixed radius r. As shown in the diagram here, one vertex of the rectangle has point xy. So xy is here. The Cartesian equation of the circle is given as x squared plus y squared equals r squared. You'll find if you plot this out, it will give you a circle. The center is at the origin 0, 0. And it will give you radius r. That means this is r. This is here is minus r. Here the y value is r. Here the y value is minus r. Here the x value is r. Minus r. Because the radius is r. And you're supposed to find area of the rectangle in terms of x only. And then show that the maximum area of the rectangle occurs when x equals to y. You'll find that there are symmetries. So you have a symmetry this way. You have a symmetry this way. And you are given this point is xy. It means here to you can actually, let me erase this first. It means you can actually say this. From here to here, the length is x. So which means from here to here, the length is also x by symmetry. Then here is y because the y coordinate is y. Then here another y. So which means if you look at the rectangle, it's just 2x by 2y. It's 2x then by 2y. So it means the area will be just 4xy. Because it's 2x by 2y. So area is just 2x times 2y. So it's just 4xy. And then you use the equation. From the equation, you can say y is square root of r squared minus x squared. So the answer is just 4x then square root of r squared minus x squared. Here is the area of the rectangle in terms of x only. And after that, you are supposed to show that the maximum area of the rectangle occurs when x equals to y. So we are going to do differentiation. And you are supposed to find maximum area in terms of r also. And you'll find that if you work out the ADX directly, it's complicated because it involves square root sign. So one way to do is you consider a square. If you consider a square, then it's easier. If you consider a square, means you square everything. You square everything. So you consider a square. So that means you square everything. So it means it's 4x square root of r squared minus x squared whole square, which will give you 16x squared bracket r squared minus x squared. You find this is easier to do. And then you give you 16 bracket r squared x squared minus x power 4. So this is a squared. And a squared is can just denote it by another letter called s. You'll find that to maximize area, to maximize a, right, is same as to maximize a squared. You want to maximize a, it's same as maximize a squared, which you call it s. And if from here, if you find ds, dx is easier because no square root sign. So we have found s squared is 16 bracket r squared x squared minus x power 4, right? So it's 16 bracket r squared x square minus x power 4. So from here, you can do differentiation. So s is 16r square x square minus x power 4. So we find d as dx, it is 16 bracket 2r square x. Differentiate x square give you 2x. Differentiate x square give you 2x. R is just a fixed number. R is constant. So just copy down. Then minus 4x cubed. Minus 4x cubed. And after that, right, you set d as dx to 0. That means it's same as 2r square x minus 4x cubed is 0. So you can divide by 2. So r square x is minus 2x cubed is 0. Then you can take out x. Then it's r square minus 2x square is 0. So x is 0 or r square minus 2x square is 0. Of course, x cannot be 0. If x is 0, then it will be just a point in the set at the origin. So with that, you have x square is r square over 2. So x will be r over square root 2. So x is r over square root 2. After finding x, you can find y. You can find y. From the equation here, you can find y. So y will be square root of r square minus x square. Then x square you can sub as r square over 2. Instead of substituting x as r over 2, r over square root 2, you sub x square as r square over 2. So it means it will be square root of r square minus r square over 2. So it's just square root of r square over 2. Square r square over 2, right? R square minus r square over 2 is r square over 2. Then you take square root, it will be r over square root 2. So with that, you realize that x and y are equal. So you find that y is r square root 2. X is also r square root 2. So with that, you show occurs when x equal to y. But we haven't shown maximum area. To show maximum area, you have to differentiate one more time. So you have to work out d2 as dx squared, which is 16 bracket 2r squared. Differentiate x gives you 1. Differentiate x cubed gives you 3x squared. So it gives you 12x squared. So which means you have to check for maximum by second derivative test. So d2 as dx squared is 16 bracket 2r squared minus 12x squared. So that means so far we have y is equal to x and y is r square root 2, x is r square root 2. So we want to show maximum. So this is what we already have. And d2 as dx squared is 16 bracket 2r squared minus 12x squared. And the x squared you just replace by this x squared, you just replace it by r squared over 2. So it means d2 as dx squared will be equal to 16 bracket 2r squared minus 12 bracket r squared over 2. We just replace x squared by r squared over 2. So with that, you get 16 bracket 2r squared minus 6r squared. So this will give you negative because it's 16 times minus 4r squared is minus 64r squared, so less than 0. Imply maximum area. Maximum area. after that you're supposed to find area. And area is actually 2x times 2y, right? Just now we notice that this length is 2x, then the height is 2y, right? So it's 2x times 2y, so it's actually 4xy, right? 4xy, so it's actually 4 bracket, x is r over square root 2, y is r over square root 2, so it's r over square root 2 and another r over square root 2, so it should give you 2r squared. Square root 2 and square root 2 will give you 2. So 2 and 4 will cancel. That means square root 2 and square root 2 will give you 2. Cancel with 4 will give you 2. R and R will give you R squared. So the maximum area is 2R squared. Occurs when x is R over square root 2, y is R over square root 2. So in fact it's a square because x and y equal. So actually you have a square.